Welcome to Numbers Simplified. In this channel, we seek to simplify and solve numerical problems. We're still continuing with our financial mathematics series. And today, we'll be looking at the theory behind annuities. So this is the part where we just explain what annuities are. And take note, this is part 11. Make sure to check out all the other parts prior to this so that you don't miss out on any of our future uploads, especially in financial mathematics. Remember to subscribe, like, and share so that you don't miss out. On any of our future uploads. So, future value annuities. What are these, you might be wondering? This is when equal payments, amount of money, are made regularly in order to acquire a specific future value with interest, of course, at a specified period. However, when the investment is to be spent on maturity, for instance, a car or house, this is rather known as a sinking fund. In this session, we will consider both the same for now because we are not specifying which one is sinking fund and which one would be the future values annuities. We'll just consider this as just one thing. Right, so a good example is that of one who decides to buy a house that is worth $300,000. However, it may not necessarily be immediately. And the goal could be in 10 years' time and without taking a loan or a mortgage. So, one approach could be that of making a monthly payment of $100 in a flexible investment account compounded periodically, for instance, monthly, at a specified interest rate. So realistically, these do fluctuate from time to time, and I'm referring to the rates, by the way. And of course, with favorable rates, among other factors, this goal could still be achievable. An additional point to note is regular payments are made normally at two specific points. For example, at the end of the month or at the beginning of each period. Therefore, allowing for an investment to earn more interest and consequently yielding a higher future value. The former is known as the ordinary annuity, and the latter is known as annuity due. So firstly, we consider the ordinary annuity with the formula that is given to be the future value is equal to PMT over R over I multiplied by 1 plus R over I raised to the power n times 1 times I minus 1. Or in a simplified and more refined manner, the future value FV is going to be PMT times I over R multiplying 1 plus R over I raised to the power n I minus 1 in parentheses. And we would refer this to equation 1, but the ordinary annuity equation 1. Right, we are going to talk about what these represent. So FV would be the expected future value that the investor is anticipating to get by the end of the investment. And PMT is the equal amount to be paid regularly by the investor. R is the decimal interest rate per annum. And this is in a case where we assume the interest rate is stable throughout the investment period. And N is the number of years. I, of course, is the number of periods in a year. So for instance, if we're talking about the compounding period, so how many times the investment or the interest is compounded within a year. So that would be that particular I. So in order for us to find PMT, supposedly we're given all the other values except the PMT, and we want to find out what the PMT would be. That is given the future value. We are going to rearrange the formula. So we instead make the PMT be the subject of the formula. So from equation 1, we see that future value is given to be that. So of course, we want to detach all the other terms that are multiplying PMT, since we are trying to make PMT the subject of the formula. So the first thing that we can actually detach from the PMT is the I divided by R. This is how we would go about it. We multiply both sides because this is an equation. So multiplying both sides by R times I. This would ensure that the i's will cancel out and the r will cancel out, the ones that are multiplying PMT immediately. So doing the same on the left hand side, we would have r over I times FV. That's the first part. Now the next thing is to detach the square brackets or pair of parentheses that we have multiplying PMT. So we can actually divide throughout by that whole chunk which is in the square parentheses. So doing so, whatever we do on the right hand side, we also have to do on the left hand side. That's how equations are solved. So if we do that, we are going to end up having PMT being equal to R over I times the future value over 1 plus R divided by I raised to the power ni minus 1. So these two are the formulae that would help us in finding either the future value or the PMT, the equal amount to be paid regularly. So we cannot just confine ourselves to these only. There are instances where we may be asked to find other variables, for instance, R, or even the N, as well as the I. So we may need to know how to find this by making them the subject of the formula. Then, of course, rearranging every other thing in order to find the expected values. So this is just one way of going about it. But in this case, we were using the PMT, which is the usual question. But if it happens to be any other variable, so the procedure is the same, and of course some procedures may involve some techniques, but we will cross the bridge when we get there. Now let's move on to annuities due. We consider the annuities due to be regular payments that are made at the beginning of each period. This would allow investments to earn more interest and consequently yielding a higher future value. The formula is given in this manner. FV is equals to 1 plus R over I times PMT times, or rather divided by R over I times 1 plus R over I raised to the power ni minus 1. So take note, the key difference between annuities due and the ordinary annuities is that because this one is being paid at the beginning of the month, each and every month, by the end of the month, it would have accumulated some interest. Therefore, it has an additional 1 plus R over I that would add to the interest. So this would result in a higher yield because it generates more interest. Each and every month, it has a month extra in which it generates interest. So that is the difference between the two. And of course, this formula over here could be further refined so that we have it as FV is given to be 1 plus R over I times PMT times I over R times 1 plus R over I raised to the power ni minus 1. So let's call this one equation 1, but for the annuities due. So that's the difference we have between the annuities due and the ordinary annuity. So where, of course, everything is still the same. FV is the expected future value. PMT is the equal amount to be paid regularly. And R, decimal interest per annum. N, the number of years. And I, it is the compounding period within a year. So now, in order for us to get the PMT, which is the equal amount that has to be paid regularly, we can consider the equation that we have on the left-hand side, equation 1, but on the annuities due. So we are going to apply the same procedure that we applied on the ordinary annuities. So the first thing would be to detach every other thing that is being multiplied on the PMT. For instance, we have the 1 plus R over I. So dividing both sides by that term, we are going to have FV divided by 1 plus R over I. The same thing happens for the I over R. If we multiply, so that's another way of saying divided by I over R. If we multiply by the reverse, R over I, what it does is it will cancel out the I and the R, that is multiplying PMT immediately, to be on the other side. But on the other side, it would appear as R over I, because that is one way of doing it. So now we have this chunk on the left-hand side, and we still have in the square brackets or pair of parentheses a part that is multiplying with the PMT, which is a variable of interest to us. The next thing would be to divide throughout by that particular chunk. So if we do that, we are going to have the PMT resulting to be R over I times FV all over 1 plus R over I times, in square brackets or pair of parentheses, 1 plus R over I raised to the power Ni minus 1. And take note, the difference that we have between the PMT in the annuities due and the ordinary annuities is that the 1 plus R over I term is part of the denominator. So if we can take note of that, it will make our lives easier, especially when we are solving questions that are related to annuities. It's something that we must have so that we are able to differentiate between the annuities due and the ordinary annuities. So in this session, this is all that we'll be talking about. It's just the intro, the theoretical part to annuities. However, in the next sessions, we are going to look at the annuities in detail with proper examples so that we appreciate what these are and be able to differentiate how to solve these particular problems. And remember to subscribe so that you don't miss out on any of our future uploads. Make sure to check out all the other playlists we have so far. They might be beneficial to you, especially if you are a mathematics, statistics, financial mathematics student. And of course, I'll leave you with the following task. Find a question and post it on the related topic. Remember once again, your questions, feedback are always welcome here. Subscribe, like, and share so that you don't miss out on any of our future uploads. Thank you for watching Numbers Simplified. Remember, God loves you.